So today we're going to be looking at the Radix sort. The Radix sort is kind of a weird sort, and to be honest, I don't know how someone kind of thought of this, but it actually works out pretty well. And so we're going to actually take a look at it. I'm going to kind of explain it as we do it. So the Radix sort requires you to look at the place values of numbers, like the ones place, the tens place, and the hundreds place, and so on and so forth. And it also looks at the current numbers. So that'll become a little more apparent once we start doing it. So let's just get into it and see how, I'll show you how it works. So the first thing we do is we have our array and go in and make a copy of this array. Right, so this is going to be a copy. Now, the copy doesn't have to have the same elements, it can be just empty, but it has to be the same size. Alright, so then what we do is we start off by just looking at the ones digits. Okay, so the current place value we're looking at is, we'll say, the ones. Right, and the current number we're going to look at is 0. And so what we're going to do is look for any number that has a 0 in the ones position. Okay, so then there's nothing. Okay, so then what we do is we get rid of the 0, and the current number then turns into a 1. Okay, so what we're going to do is look for things that end in a 1. Okay, well, there's 71. So what we do is we copy the 71 here and paste it. We just copy it into here. Okay, into the new one. Then we have 491, that ends in a 1. Alright. Okay, and then that's there as well. Okay, we keep going, nothing else ends in a 1. Okay, we continue looking for 2s. Okay, so the next number we're looking for is a 2. Okay, 222 ends in a 2. Alright, so we'll throw that in there. Boom, 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 boom. Nothing else ends in a 2. Alright, so the next number is a 3. Alright, looking, let's see, so nothing ends in a 3. Okay, so the next number is a 4. Alright, so remember, we're still looking in the ones digits. Okay, so 744. It's copied into the next spot. Alright, just the number 4 gets copied over. And nothing else. Okay, now I'm going to stop just changing this number here. Alright, and I'll just put an N there. Just because it's just time consuming for me to continuously go and update that number. Alright, but we'll continue this here. So the next thing we're going to do is look for 5s. Okay, there's no 5s. We're going to look for 6s. There's a 6. Okay, another 6. Now the important thing is that you have to go from left to right, and you have to keep them in the order that you found them. Alright, so looking for more 6s, there's nothing. Looking for 7s, so something that ends in a 7, there's a 7. Okay, and another 7. And 8s, so nothing ends in an 8. And then 9 is this number here ending in 9. Great. Okay, so now we have this array. Now, the copy of the array doesn't appear to be in any better order than the original array. But what we can do is we can actually repeat this. So what we're going to do is, in some cases, some people will tell you you got to copy this array. You got to copy the copy back into the array. You don't actually have to do that. In Java, well, I guess it's language dependent, but in Java you don't have to do that. Because the name of the array is not permanently bound to the object, you can just say array is equal to copy. And what that will do is that will essentially just move its name down here. Alright, actually what it does, a better illustration is it moves it like this. So now this array has two names, and this array has no name, and because it has no name it gets garbaged. Alright, so it gets collected by the garbage in Java. Alright, then what we do is we can say something like copy So we'd say copy is equal to new int, and just make it size 10, or size, I guess it would be. Okay, so something like that. And what would happen then is the copy would get reassigned, okay, back to a new empty array. Right, so something like this. Okay, so back to a new empty array. Now, I'm going to have to erase these arrays here, so just give me a second. Okay, so after we did everything, our copy is were reset and everything. So, okay, so our copy is reset. Now I'm just going to put these back how we had them originally. And I can't do that. Let's just do this. And we'll just push this up. All right. So we've reset. Now we're not looking at the ones spot. Instead, we are going to move up a place value, and now we're going to look at the tens. Okay, so we're going to look at starting at 0 and see what we can find. So what do we have? 0 is here, so this has a 0 in the tens position. In fact, I'm just going to cut it out, although in reality you wouldn't actually cut it out. Okay, I just want this to be empty later. Okay, so 0 in the tens position. Here's a 0 in the tens position. All right. Okay, looking for ones in the 10 position. There's 1. And remember, I am doing this in the order that I find them, from left to right. Okay, looking for 2s. There's a 2. Okay, looking for 3s. No 3s. Looking for 4s. There's a number with a 4 in the tens position. Another number with a 4 in the tens position. Another one. All right, and then 5s, 6s, 7s. There's a 7 here. Okay, then 8s and 9s. Okay, so there's a 9, and there's the last one with a 9 in the tens position. Now, again, if you look at the copy of the array, there's really no real order to it. It doesn't seem like it's in any better condition either. Okay, but let's keep going. We're going to repeat this again. So what we do is we say array is equal to copy. So we move this down here. And then we say copy is equal to new array, so new integer array of size. Right, and so things move up like this. Okay, so we can essentially just kind of reset the board. We cut this out. I'm just going to put everything back, okay, how it was. Okay, and this time we're going to look at the hundreds position. Okay, so let's actually just delete this first. Okay, so now we're going to look at what's in the hundreds position, and you'll see what happens here. Okay, so we're going to look for things that end in 0 in the hundreds position. We'll have, so the 4, all right, has a 0 in the hundreds position. The 71 also has a 0 in the hundreds position. Okay, then we're going to, oh, yeah, that's right. So then we're going to look for things that end in 1 in the hundreds position, and there's a 1 there. Okay, anything else? Nope. Something that ends in a 2. Okay, so 2 there. Anything else? No. 3s. Yeah, you got a 3 there. So 3s right there. 4s. Boom. 5s. 6s, none, 7s, and 8s and 9s. All right. So what you can see there is now, if you look at the copy is actually in order, right? So the key is that we're going to start, you have to know the highest place value, right? And we're going to search for that, right? Or I guess you can just have it embedded in your programs if you like, depending on your situation. And then what we're going to do to recap is you start in the ones position and you start looking for things that have 0 in the ones position, and then 1 and 2 and 3 all the way up until 9. And then you move into the tens position and you're looking for, again, 0, 1, 2, 3 all the way to 9, and then hundreds and then thousands and so on and so forth. Whenever you find one, what you do is you just move it down and copy it in the same order you found it from left to right into the copy. And then at the end, before every iteration, what you do is you say array is equal to copy. So you set this array to be the copy, and you you say copy is equal to a new array, and that will make the copy into a new array. Okay. Alternately, you could do a copy, like an actual copy operation, and copy the whole array, like the modified array, back into the original. But you shouldn't do that because if you can avoid it, because it takes a lot of extra space, right, or a lot of extra time to do that, and it's just expensive operationally. So anyways, that's how the radix array works, or the radix sort works. It's a little bit weird, but it actually is quite an effective array sort algorithm, right? So anyways, if you have any questions, leave them in the comments. I hope you enjoyed this video. Thanks for watching. See you next time.